The Sun, our friendly neighborhood star, has fascinated humanity for centuries. Its warmth and light sustain life on Earth, but it also holds many mysteries. What goes on beneath the Sun's blazing surface? How does it affect our planet and the entire solar system? To answer these questions and more, India embarked on a remarkable journey to explore the Sun with its first solar mission, Aditya L1. Before we dive into Aditya L1, let's take a moment to understand why studying the Sun is so crucial. The Sun is not just a bright spot in our sky, it's the powerhouse of our solar system. Everything in our cosmic neighborhood, including Earth, depends on the Sun's energy. The Sun's role in our solar system. Energy source. The Sun is like a giant, self-sustaining nuclear reactor. Through a process called nuclear fusion, it converts hydrogen into helium and releases an immense amount of energy in the form of heat and light. Planetary influence. The Sun's gravitational pull keeps all the planets in our solar system, including Earth, in their orbits. Without the Sun's gravitational force, everything would drift aimlessly through space. Weather and climate. The Sun's energy is the driving force behind Earth's weather patterns and climate. It warms the planet, causing air currents, ocean currents, and the water cycle, which in turn shape our weather. Solar wind. The Sun continuously emits a stream of charged particles called the solar wind. This solar wind affects the entire solar system and can even disrupt our technology, like satellites and power grids, when it's particularly intense. Space weather. Solar flares, eruptions, and other solar phenomena can impact our technology and even pose risks to astronauts in space. Origin of life. Some scientists believe that the Sun's energy played a role in the development of life on Earth. Understanding the Sun's history could help us uncover more about our own origins. Given its critical role, it's no wonder scientists are eager to explore and understand our Sun better. This brings us to India's Aditya L1 mission. Aditya L1 is a solar mission developed by the Indian Space Research Organisation, ISRO. Its name, Aditya, means sun in Sanskrit, which is fitting for a mission aimed at unraveling the Sun's mysteries. Let's explore the key aspects of this exciting mission. The mission objectives. Aditya L1 has several primary objectives, each of which contributes to our understanding of the Sun and its impact on our planet and the solar system. Studying the solar corona. The Sun's outer atmosphere, called the corona, is hotter than its surface. Aditya L1 aims to investigate why this is the case and what processes drive the corona's extreme temperatures. Solar magnetic field. Understanding the Sun's magnetic field is crucial. Aditya L1 will observe the Sun's magnetic field and how it influences solar activity, such as sunspots, solar flares, and coronal mass ejections. Space weather prediction. As mentioned earlier, solar activity can affect technology and space travel. Aditya L1 will help improve our ability to predict space weather events, which is essential for safeguarding satellites, astronauts, and power grids. Solar variability. The Sun's energy output is not constant. Aditya L1 will monitor solar variability and its potential impact on Earth's climate. The Aditya L1 satellite. The heart of the Aditya L1 mission is its satellite. This advanced spacecraft is equipped with a suite of scientific instruments designed to observe the Sun in various ways. Here are some of the key instruments on board. Visible Emission Line Coronagraph, VELC. VELC will capture high-resolution images of the Sun's outermost layer, the corona, in visible light. It will help scientists understand the dynamics and temperature variations in this region. Solar Ultraviolet Imaging Telescope, SUIT, will observe the Sun's ultraviolet emissions, providing valuable data about the temperature and density of the solar corona. Plasma Analyzer Package for Aditya, PLAP. PLAP will measure the solar wind's properties, helping scientists understand the interaction between the solar wind and Earth's magnetic field. Magnetometer. This instrument will measure the strength and direction of the Sun's magnetic field. Solar X-ray Monitor, XSM. XSM will monitor X-ray emissions from the Sun, particularly during solar flares. Aditya Solar Wind Particle Experiment (ASPEX) aspects will study the composition and characteristics of the solar wind. These instruments work together to collect a wealth of data about the Sun, allowing scientists to piece together the puzzle of its inner workings. The Aditya L1 orbit. Aditya L1 will be positioned in a unique orbit known as the Lagrange 1, L1 point. This location offers several advantages for solar observation. Stable position. At the L1 point, Aditya L1 can maintain a nearly constant distance from both Earth and the Sun. This stability is crucial for continuous solar observations. Uninterrupted view. From its vantage point at L1, the satellite will have an uninterrupted view of the Sun, free from the interference of Earth's atmosphere. Data relay. Aditya L1 can relay its data to Earth in real time, ensuring that scientists receive up-to-the-minute information about solar activity. Collaboration with international partners. Solar research is a global endeavor, and Aditya L1 is no exception. India has collaborated with international space agencies and organizations to maximize the mission's scientific output. This collaboration allows scientists from around the world to work together and gain a more comprehensive understanding of the Sun. Launching a satellite into space is no small feat, and Aditya L1's journey to the L1 point is a carefully orchestrated mission. Launch and transit. Aditya L1 will be launched into space atop an ISRO GSLV Mk3 rocket. Once in space, the satellite will embark on its journey to the L1 point. This journey involves a series of precisely calculated maneuvers to reach its destination. Deployment and operations. Once Aditya L1 reaches the L1 point, it will deploy its instruments and begin its scientific observations. These observations will continue for an extended period, allowing scientists to collect a wealth of data about the Sun's behavior over time. Data collection and analysis. The data collected by Aditya L1 will be transmitted back to Earth, where scientists will analyze it. This data analysis will involve complex mathematical models and computer simulations to decipher the Sun's secrets. International collaboration. Throughout the mission, Indian scientists will collaborate with their international counterparts, sharing data and insights to advance our understanding of the Sun. Please like and subscribe my channel. Thank you.